Hello, everyone. This is in continuation to our testing of hypothesis problems. The next problem is two drugs meant to provide pain relief to arthritis sufferers were produced in two different laboratories. The first drug was administered to a group of 12 patients and produced an average of 8.5 hours of relief with a standard deviation of 1.8 hours. The second drug was tested on a sample of 8 patients and produced an average of 7.9 hours of relief with a standard deviation of 2.1 hours. Test the hypothesis that the first drug provides a significantly higher period of relief. You may use 5% level of significance. First of all, let us capture the information being given in this particular question. It talks about two different laboratories. Let me put it like lab 1. These are all given. Lab 1 and lab 2. I think. Let me, sorry. First drug was administered to group of 12 patients. So I will say sample size. This is drug 1 in lab 1, drug 2 in lab 2. Patients, group of 12 patients it says. So N1 is 12. And it produced an average of 8.5 hours of pain relief. So sample mean for this 12, they got these values. 8.5 hours, which is x1 bar. This is in hours. Then with a standard deviation of 1.8 hours, sample standard deviation. This is also in hours, 1.5. That is our, sorry, 1.8. 1.8, not 1.5. That is our sample standard deviation. So we write S1. Then the second drug was tested on a sample of 8 patients. This is 8 N2 and produced an average of 7.9 hours of relief. With a standard deviation of 2.1 hours. S2. Test the hypothesis that the first drug provides. First of all, let us define. Let mu1 is population mean hours of pain relief due to drug 1. Mu2 is population mean hours of pain relief due to drug 2. What is that to be tested? Test the hypothesis that the first drug provides a significantly higher period of relief. Means to test or to check whether mu1 is greater than mu2. That is what to be tested. So it actually, the test is concerned with two population means. The above test concerning with two population means. Then we may note sample sizes are not large. Both samples are not large. So I will write here, since sample sizes are not large and population standard deviations means the sigma 1 and sigma 2 are unknown, we will use t-test. We'll use t-test. The relevant t-test statistic will be tcal under modulus is equal to modulus of x1 bar minus x2 bar minus of mu1 minus mu2 under h naught, the whole thing divided by the standard error, where this standard error is sigma times square root of 1 by n1 plus 1 by n2. Let us continue in the next slide, where sigma square is nothing but n1 minus 1 times s1 square plus n2 minus 1 times s2 square, whole thing divided by n1 minus 1 plus n2 minus 1. Now these are the values which are available. Now before I proceed, first I need to write down the hypothesis, null hypothesis, alternative hypothesis. If you look into this itself, do not have any equality sign, so I can consider this as alternative hypothesis. mu1 greater than mu2. So null will be, there is no significant difference, both are same, which means mu1 minus mu2 is 0. Now, first of all, let us calculate this value. n1 minus 1. n1 is 12. 12 minus 1 becomes 11 times. s1 square is 1.8 the square. n2 is 8. 8 minus 1 is 7. 7 times s2 square. s2 square is 2.1 the square, divided by n1 minus 1 is 11. n2 minus 1 is 7. So this sigma square value will be 3.692, which means our sigma is root of this. That will give you 1.92. Therefore, standard error, which is sigma times root of 1 by n1 plus 1 by n2, will be 1.92 times root of 1 by 12 plus 1 by 8. If we calculate this, we get the value as 0.876. Now we have to find the t calculated value. Therefore, tcal, which is modulus of x1 bar is 8.5 minus x2 bar 7.9. Minus of mu1 and minus mu2 under h0 is 0 that we have here. Under h0, mu1 minus mu2 value is 0. So divided by the standard error. Standard error is 0.876, which we calculated previously here. It is available here. We substitute that. So if we calculate this entire thing, we get the value as 0.685. Now, T tab is T table value at 5% level of significance. Let us go back here. This is actually a one-tail test. At 5% level of significance for a one-tailed test at n1 minus 1 plus n2 minus 1 degrees of freedom is equal to P table value at 0.05 LOS for a one-tailed test at what is n1 minus 1, n2 minus 1? Here we have, it is 18 degrees of freedom. At 18 degrees of freedom will be. So we have to capture the table value from T tables, directly going in for 5% level of significance. And for the tables are anyway, it is one-tailed test values only. Let me remove this. Degrees of freedom. So from the tables, we get the value as 1.734. So now we have a table value and we also have a calculated value. So the next step is the inference. Since Tcal, which is equal to 0.685, is lesser than T tab, which is 1.734, we accept null hypothesis. That will be the conclusion for this particular problem. In case if you find the contents of the video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.